We'll now jump into how each of these technologies work, and we'll start with incineration. And that's because it's kind of the default, oldest, simplest, most widely used form. As we touched on, that it was practiced with no emission controls in rich countries until the mid 20th century, and it's still widely practiced across the world as a waste management technology. Its identifying characteristic is using excess oxygen, and that's encouraging all the material in the waste to be oxidized, and we'll just be left with the ash at the end, and everything organic will be burned and turned into carbon dioxide or another combustion product. The outputs of the process are an ash that's decreased in mass greater than 75% typically, and volume 85 to 90% reduced. So this really highlights the big advantage of thermal treatment. And then kind of the useful side effect is the energy you also get. So on average, around 10,000 kilojoules per kilogram. And then because we don't need a big landfill site that we're going to fill up over decades, we just have one plant. We can potentially site these closer into cities now that we have better air pollution control technologies. So that's another advantage, just kind of operationally and on the round trip greenhouse gases. And within incineration, there's two types of plants that you'll see. The first is called mass burn, and then the second is called a modular. Within incinerators, because they have different advantages, right? There's the energy recovery aspect, the waste mass reduction aspect, and volume reduction. And then also we're worrying about pollution minimization. There's different variables that we might be trying to maximize and minimize based on what our outcomes want to be. From a solid waste management lens, the real focus is on the ability of that plant to accept different types of waste. This is kind of the best practice thing you want to maximize in order to make sure your plant's going to be economical to operate over a long period of time. And this might mean sacrificing some energy production if you're going over the most types of waste versus just the most valuable waste for heat. But from a waste perspective, you really want to get the most waste in the door. And this diagram on the right side of the screen here is a capacity diagram for a mass burn incinerator. And it just shows you kind of the different variables you'll have in mind when looking at these plants, and then also the range of waste that these types of plants can accept. So the y-axis here is the steam production. So this is the energy recovery that's possible. And then the x-axis here is the fuel throughput in kilograms per second. So how fast is waste being loaded into the incinerator? And then these diagonal lines are different energy contents of waste. So here's 10 millijoules per kilogram that we just mentioned. And then here's a little bit lower, and then you can even go much higher than that. So the higher the value of the waste, as you increase the throughput, the energy recovery will increase, and it will increase at a higher rate based on the calorific value of the material. And then this shaded area in the middle is what would be accepted by this particular plant that is being analyzed. So we can't accept waste above this energy content, 17.8 megajoules per kilogram at all, or anything below. This is going to get too hot. This is going to not be able to sustain itself. And then we can't handle any net energy above this, any net energy below this. And it's this region in here where we're able to balance all these factors and actually have the plant be able to sustain itself on different types of waste. So maximizing the size of this shape in the middle here means that the plant is most able to accept a variety of waste, which is kind of where you want to be if you're an incineration plant. If you were, say, a coal-fired power plant, then you wouldn't be really as focused on accepting as much fuels. You'd really be focused on the energy side. So maybe your range would be really focused over here. But for an incinerator, since we have multiple goals, this large area is kind of characteristic. The first type of incinerator we'll look at is a mass burn type incinerator. And before I show you the parts of it, I'll get you to watch this video. This is for the Amsterdam incinerator, which will walk you through and show you all the steps. And a lot of them will be similar to things you've seen before. So as you go through the video, you can think about these questions. So number one, how is what you see the same and different from other solid waste facilities we've seen, such as MRFs and AD plants? How is the incineration reaction itself controlled and facilitated? How is energy recovered? How are materials recovered? And then see if you can spot the two different types of ash that you get from incinerators, and what are some of the environmental and health hazards that are present with this technology, and what is in that plant that helps mitigate each of those. So I'll leave you with this video, and then we'll come back and we'll step through each step of how mass burn incineration plants work.